Welcome to this webinar of Breaking Barriers, Open Innovation Insights. Today we're going to talk about why aligning AI metrics with business metrics is critical for organizations. So let's jump right in. As we know, AI is gaining a lot of momentum for good reasons, and there are a lot of use cases which are being recognized across industries. But there is this high misconception that high performing AI guarantees business success. The truth is, AI metrics alone don't drive outcomes. And it's critical for organizations to realize that on one side, you have these business metrics, and on the other side, you have these AI metrics. And assuming that to achieve your business objectives, you have these AI use cases to go with. And they are the use cases which you feel will enable some of your business objectives. These AI use cases come with AI metric, like how we measure success from these AI models or machine learning models. I'm going to use AI and ML interchangeably in this presentation. And this alignment is very necessary, very important, that depending upon your business objective, what's an appropriate AI metric to use. So one thing we need to understand right away that AI metric is not your business metric. They're totally different measures. Business metric, of course, that's where every organization starts. I mean, nothing is changing from that domain. I mean, business metric stays as they were before AI, and they will stay as is after AI. So business metric may involve revenue growth or retention of your customers, for example. AI metric, on the other hand, entails evaluating your model, the AI model that you have built, and there are certain measures we put in place to measure the performance of your machine learning model. So totally different concepts. So let's get through this step by step. And so why this alignment is necessary? Assuming that in your industry you have identified use cases which are AI use cases, and you believe that by deploying those solutions, you will be able to achieve your business objectives. That's the key. Why alignment is necessary? As in any solution, misalignment leads to lost resources, lost time, money. And what we need to ensure that these AI metrics must enable business outcomes. And what's also important, when we pick these AI metrics should ensure that they lead into some measurable impact. It means they are directly contributing toward your business objectives. That's the goal. So let's talk about a framework for this alignment between business metric and AI metric. You always start with business objective. That's not changing. Means any solution should contribute towards your business objective. What comes next? Assuming that you have gone through your assessment of your business objective, you have set goals for the organization, and then comes solution, like how you're going to achieve those business objectives, and your team has identified certain AI use cases. So what do you need to do first? As soon as you identify your business objective and you identify some use cases, you have to map those to your business metrics. Next comes your AI metrics, assuming that your use cases are AI-oriented use cases, which are eventually leading up to enabling your business objective. As a very critical step, and that's where we'll spend a lot of time in this presentation talking about it, like why it's very critical to identify the right AI metrics for your solution. So in this step, we pick AI metric. And then, of course, we go through design and development and then deploying the AI solution. Where in design and deploy, we typically, if it's supervised learning, of your model, we look at the historical data that is available with right labeling, for example, and I'll walk you through a use case and you will see it. And that data is actually, you train your model on training data set, and then you move on to your test, and then depending upon how it's performing, you decide whether to move it to production or not. And at the end, the goal is whatever we are doing through these AI solutions, they should add towards your business objective and business goals. And that's where you start to measure how these AI metrics are impacting your business, how it's enabling what you have set as goal for your organization. And that's where you start to measure success from these AI models. And depending upon the performance, as you get more data, as you learn more, you refine and iterate. And this is not a linear process, it's a non-linear process. What I'm showing here is just for common understanding, like what are the typical steps you need to follow. So let's take one use case to understand what I mean by why it's critical for organizations to align their AI metrics with business matrices. So the case we're going to discuss today, it's about patient churn prediction, their retention, and cost optimization. Cost optimization from the perspective of how much money you're going to spend on retaining those customers once you have identified a segment of patients that you think are at risk of leaving your practice. So the case study is a hypothetical situation, but it can very well be applied, and it's a very real situation for a lot of clinics. And the example I'm sharing with you is as a setup. There's a clinic of pain management. It's a chain of pain management clinics, and the clinic is facing some churn. I mean, there is a turnover. Patients are leaving, and they are deciding what they need to do in terms of retaining those patients, and to ensure that they target right at-risk patients so that they can tailor some of those retention strategies. So here's a business problem, objective, and AI solution as a AI solution proposed as a solution for implementing these business objectives. So here's a business problem. There's a clinic, and it has about 10,000 patients, and they're facing 20% churn, which is about 2,000 patients per year. Average revenue loss is about 10 million per year, which comes to about 5,000 per patient. Business objective here is to reduce churn by 10%, retain 1,000 patients in 6 months. That's the goal they have set up for themselves, which translates into about 5 million in revenue retention. And a solution proposed is a machine learning model to predict patient churn. And since it's an AI solution, we have some costs associated with building these AI models. So we are saying it'll cost about 200,000 to build this AI model. And then there's some retention cost per patient around 250. That's the number that's given to us. Now, let's understand some of the key AI evaluation metrics for patient churn. This is a typical classification problem in machine learning. So it's a yes or no question, and it's basing that information based on number of features, a number of fields, number of data, like the data that you may have collected on patients over time. And that data may include, for example, their demographic data. It may include their income. It may include their family size, or there are a lot of different permutation and combination of data that you have collected over time. There might be some survey data. You may have conducted some surveys, and you may have gotten some feedback. So there might be some sentiment analysis done on patients. And based on that data, you train your model to predict whether patient is going to leave or not. Now, when we train AI model, since it's going to be supervised model, it's a classification problem. you already know, or historically, based on the data that you have gathered, you already know who are the patients who left and who stayed. So you have that information already available to you, and you build that model, your prediction model, based on the churn that has already happened, and also, of course, based on the data you already have gathered about those patients. There are certain metrics we use when we talk about prediction, like classification problems, and they're listed here. So accuracy, recall, precision, and FN score. We'll talk a little bit more on those. So a little bit about these metrics which are used for classification problem. Accuracy is pretty straightforward. It's a pure measure of how well your model has predicted, and it entails both, like how many it predicted that um, true positive, meaning model predicted that 100 patients will leave and actually 100 patients left. Model predicted 2,000 patients will not leave and 2,000 didn't leave. So that's a pure number in terms of measure, like how well your model predicted, both yes and no. The next metric here is recall, which measures the sensitivity, which is actually measuring the actual positive correctly identified. Means how many patients were correctly identified. The goal of this recall measure, or the metric that you're seeing on the screen, is to minimize on false negatives. So basically, as you minimize on false negatives, the performance of your, or the recall number goes up. The next matrix is precision, which is positive predictive value, which talks about proportion of positive prediction that are correct. The goal for this metric is to minimize on false positives. And then comes the FN score. FN score combines both recall and precision, and it comes up with another number. And you will see that as we go through this use case. Now let's quickly talk about a confusion metric. As I was saying, there's some false positives, false negative, and which is purely our way of, let's say you have built a model, and then you have deployed it in production, and over time data is flowing into this model and data is coming out of that model. And what's coming out of this model we already know is a classification problem. So it's just predicting whether the patient is going to be staying or leaving and like that. Now, those prediction can be right or wrong. So what we do when we run, when we gather results, we try to create this confusion metric, which is a good measure of seeing how your model is predicting and how model is performing. So there might be situations where your model predicted true positive, meaning patient, it said patient will churn, patient will leave the practice. In reality, it happened that patient left. So which is true positive? Both, so prediction in real world and prediction by AI model matched. So nothing wrong with that. Same goes with true negative. And in real world, patient stayed, and your model also predicted that patient will stay. So they matched. The real problem comes when they're false positives and false negatives. Your AI predicted that your patient will not leave. But in reality, patient left. So there is a mismatch happening here. And the same goes with false positive. In your AI predicted that your patient will leave, but in reality, your patient did not leave. So these are the mismatches, and these are some of the things you want to minimize on your model as you deploy this model. So let's talk a little bit more in the next slide. So let's assume, based on your business objective and business goal, you decided to pick on accuracy. So let's see how it's going to play out. So as we know, accuracy is a pure measure of right predictions, true positives, true negatives, pure math. So scenario here is your model achieves 80% accuracy on test data. It's good, not great, but it's good. And you take that model and you deploy it into production. And this is what happens over time as data flows in and you run this your patient data through the model. It recognizes that their true positives are 400, true negatives are 7600, false positives are 400, and false negatives are 1600. When we say true positives, as we said, these are the actual churners you feel they will leave your practice. So what ends up happening now in this scenario? Your model identified that there, with confidence, that there are 400 churners, possible churners, and you need to focus on them. Resources are allocated to target these 400 churners for good reasons, because model predicted it. And we run some numbers with those. What's the biggest problem with this metrics is that you have missed out on significant churners because the focus of accuracy is not on true positives. So now what we do, we retrain our model using these evaluation metrics, and our recall achieved 90% success performance. And it identified 1800 churners because the focus is on true positives and we are trying to minimize on false negatives. And then we focus on precision too, and precision gives us 80% performance, and that flags 2,250 churners, and in the end, of which 1,800 are correct. Now check how just choosing different metrics, how numbers are changing all over now. Again, so revenue retained here is based on 1,800 churners that our recall and precision also identified. We are able to retain 9 million in revenue, but then you have to subtract the cost of AI model development and then retention cost, the total of 650,000 subtracted from it. In the end, the total net revenue that business is able to retain by these measures of building AI model with right metrics comes down to 8,350,000. And with using recall, precision, and FPIN together, you're able to retain $8,350,000. Effective churn prediction is essential for targeted retention strategies. So when we talk about churns, means like how you're trying to predict how many patients will stay and how many will leave. For those kind of scenarios, recall and precision and F1 are best metrics because they provide deeper insights compared to accuracy, especially when class imbalance is present. And we will talk a little bit about class imbalance and what happens, especially when you're talking about churns. Usually in a real world scenario, uh, unless your business is really doing very bad and there's a lot of churn, like 50-60% churn, usually there is imbalance historically. So you may see that to every, let's say, 100 patients that you have, only 20 are churning. So what ends up happening in those scenarios when you're trying to train your model based on historical data, based on the churn that has happened in past, your data is very imbalanced because you only have 20% churns against 80% non-churn. When you use accuracy as a metric, the chances are your model is going to be overfit, and every time you run your data through this model that is based on accuracy, it will keep on returning no churn, no churn, no churn, because it was trained on the data which was very imbalanced. And accuracy doesn't work in those scenarios. Usually accuracy is not good for that reason unless you do some data augmentation and rebuild your model by augmenting your data so that this class imbalance of 20% to 80% is somehow adjusted. But you have to be careful with that too. When you start to manipulate the data, and there's other factors starts to come in. So you have to be very careful when you start to augment and try to manipulate the raw data. Now here's another big point. Well, recall is important when you're trying to catch potential churners because the reason being it reduces false negatives. So if you looked at the formula, false negative is in the denominator. And just by reducing false negative number, you're already bumping up your recall value because there's two positives in numerator and there is a sum of true positive and false negative in denominator. And as you're reducing false negative, that means your recall value will continue to go up. The focus of that metric is to ensure it predicts churners with high accuracy. You are already ensuring that you are focusing on patients who are truly at risk. But there is a trade-off here. High recall may increase false positives because you're trying to reduce false negatives, and that might have a negative impact on false positive, the part that this metric is not catching. We bring in precision in our calculations. Why we are bringing precision here? Because for recall, as I said, means it's helping you predict better on churners, possible churners. Precision, on the other hand, will help you focus better on your retention efforts. Because business objective is a balance of both. You're trying to reduce the churners by putting in some retention strategies. You have to spend some money in retaining those customers, so those patients. That's where precision comes in. It minimizes unnecessary retention efforts, first of all, and then optimizes resource allocation and customer satisfaction. The trade-off again here is high precision may lower recall. So these two matrices, they work together in conjunction in this scenario. So you need both recall and precision. If it's only purely just determining who are at-risk customers, you are good with recall. But since you're also trying to put in strategies to minimize on your expenses on retention, and it's also about targeting right patients that are at high risk of leaving your practice. So what ends up happening? Let's say you identify a patient and you activate that retention strategy on that patient when patient is not even thinking or leaving. So that's a lost investment. You're already losing money. So when you choose precision and recall together, on the one hand, you're targeting the right patients who are at high risk of leaving. And on the other hand, you are also minimizing on your like identifying. Means you're not spending money on patients who are not even going to leave. So that's the balance you get by using these two metrics. And F1 brings both of these metrics together. So in the end, if you can just focus on F1 metric, you will get the benefits of both, like identifying high risk churners in your patient population, and then optimizing on your retention efforts. So here, that's the key here. I think so. As we try to deploy these AI solutions, we have to get very smart and practical in using right metrics to achieve the right results. That's the goal. So again, a little bit more why not accuracy. As we already captured, churn cases are often outnumbered by non-churn cases. It's a class imbalance problem. As I said, means usually when you're predicting churn, your data may be very highly unbalanced. And again, I mean, accuracy, you may have high accuracy. You can even go to 95% accuracy, but that would not mean that you have identified the right patients at risk, because it's just a true measure of right prediction. And that right prediction can be whether patient is going to leave or not going to leave. And accuracy will just tell you as a number holistically. It's not focusing on the at-risk patients. It's focusing on the true prediction, which is a good thing too, because you want to make sure that they're true predictions. Your model is performing at high level. But this metric is not good for the business objective, the business metric that was set in the beginning, like minimizing on the churn, retaining patients at risk, and then optimizing on cost of retention. So these are some practical scenarios. Again, so if you have a problem where you are trying to reduce, optimize on retention cost, you bring in precision. Churners, of course, we saw the numbers. We were talking about 10 million in revenue lost because of 20% churn every year. The focus was to reduce this churn by 10% for next 6 months, and along with that, ensuring that the retention cost is very much optimized so that you are targeting the right population of at-risk patients. And then when you have to balance it out, you use F1 as score as a metric, because it brings the benefits of precision with the benefits of recall. You bring it together, and this metric is achieving what truly your business objective is. This is again just reiterating that is very important when you are starting out on these use cases in an organization. This is just one example. There are multiple other metrics out there, and there are a lot of different metrics which are used for different purposes. This is just to give you an idea. As you are identifying use cases, one critical aspect of identifying AI use cases, matching with your business use cases, business metrics, or business requirement, business objective, is to pick on right AI metric. So you may do good in identifying business objective, and you may do good in identifying AI use cases to go with those use cases, but you might fail in identifying the right AI metric. The key here is, well, you can also try a different metric. I think it's always a good practice to intuitively know which metric to use for what scenarios. And it's not that difficult. You can be creative. And I think as you start to apply and build more models, this will come very easily. I think it'll become a second. You won't even think. I think you will become so used to analyzing like what metric should go with what use cases that you won't worry about it. But as organizations are still learning, it's very critical to know which metric to use for what scenario. Again, remembering, even after you do all of that, you may still not be able to achieve your business objective, because AI is just another tool, and that's how you should treat it. But it's also equally important to pick on the right AI metric. And I think one of the very powerful statement, as you're seeing on the screen, which talks about AI must drive financial impact, not just technical success. So when we talk about these AI metrics, we're talking about the technical measures, like how well your model is performing, how accurate it is, what's recall value, what's precision value, what's F1 score, what's blue when you're talking about generative AI performance, for example. Blue is a big one. Let's say you have some clinical reports coming in and you want to generate automatic summaries from it. And then you compare it with human generated summaries, and that's where you try to compare and see how it's performing. That's where blue comes in. So there are a lot of different metrics which can be used. And you might also see is that for one use case, you might be using multiple metrics, as you have seen here. We're using practically three metrics for this patient churn. We're using precision, we're using recall, and then bringing them together, and we're using F1 score. And you might see that playing out for many use cases. So it's not just one metric which will be achieving your business goal, it could be multiple. But you learn as you go. The big piece, as you saw, in was about cost of building AI models. Some suggestions on that. I'll try to cover a little bit more on that in our next webinar. But just to give you an idea, means we set 200,000 as a cost for these AI model, but in all, like where all of this is heading, AI models are going to be commoditized. I mean, AI models practically being built for different scenarios, different use cases. So all you need to do is do a little bit more research, try to find if there are open source models out there, try to bring it in, fine tune a little bit on your data so that you're not building a model from scratch. You're not training your model from scratch, which is costly. So use open source, use pre-trained models to reduce cost. And there are a lot of other services available. I think, one of the things I always say means if you have a choice to use some services like AWS and other, like, don't bring a lot of these services in-house, play with them, build minimum viable products, understand how they're performing, and once you feel comfortable, start to bring that in. So these are certain ways you can minimize on your model development cost. And then there is also obviously, like, over time, you need to improvise on this precision, recall, and F1 score, the metric that we chose. And how do you do that? You have to constantly monitor your model and see how it's performing. Without monitoring, it may end up that your model start to deteriorate. The performance may start to deteriorate because a new data set may be flowing in. And there may be another dimension of data that might be coming in that wasn't there before. So now your model have to account for those new data sets, those new features. The big part in model development is something called as feature engineering. And in a very simple language and very simple, easy to understand way, you think of feature as a single data set which is critical for model to perform better. So this give you an example. So for if you take this example as the one that we just did, the use case of patient churn. Let's say as you are building this model, there is something called as feature engineering, and then you can do some math, you can do some testing to determine which features are important. And when we say feature, let's just talk about fields, which fields are important for your data. And you might recognize that income is very important. So you can list those features, that data, those data fields by priority, and then you'll say income is important. A zip code is important, for example. Depending upon where you're living, that might also determine whether patient will churn or not. And then over time, as you revise these models, you get an idea that, out of these 100 fields or 100 features that I have, the top ones which are actually contributing towards my model performance are just these 20 features. So I just need to focus on those. I can discard the rest. Well, you won't discard the rest, but you will pay more attention to those top 20 because they are contributing the most towards your model performance. But this is not a one-time thing. Over time, it might happen the income factor may go down in the list and other factor may start to come in. So I think these are some of the things that you have to play with over time. And so over time, you have to constantly monitor the performance and constantly feed new data and take actions. The idea here should be your model performance should improve over time. It should not deteriorate. That's the idea. And one another thing, and I try to capture that in one of my other presentation. Um, it was mostly it was around innovation and how do you bring innovation into the mix when you're trying to identify use cases and how you build it. So, for example, you may set F1 score, you tested it in your test database, data set, and the number you got was 84%, as you saw. So that becomes your baseline, and you go with it. But over time, your goal should be to improve that number from 84.4 to maybe next number is 86%. That's the beauty of building these AI models. You can be very agile, you can be very lean, and incrementally you start to build. And so think about some of these aspects of your AI development, and obviously along the way, don't lose sight of business metrics because it has to feed into that. So I will conclude here. Just wanted to quickly share with you my thoughts, like why it's very important to select a right AI metric for your AI use case, and that AI use case leading into your business objectives. And it's very important for multiple reasons, as I shared. The biggest is AI models, as it stand today, they are very costly to build. The data that you need, you may not have your data. So if you have to include, you have to buy data from somewhere, that's also adding up cost. So what you have to ensure that whatever you're doing, you don't lose sight of aligning your AI metrics with business metrics and vice versa. And again, the key here is everything starts from business objective, business goal. That isn't changing. The only thing that's changing in today's world is now we are bringing AI into our processes, and we are trying to enable our business objectives through AI solutions. Thank you so much. I hope this helps. And if anybody has any question, please post it on my YouTube channel, and I will try to respond and look forward to more presentations like this. Thank you very much.